I'm going to maximize this window. And hey, Ben, can you hear me? Ben, can you hear me? Well, apparently he can't.
Yes, we can hear you.
You see, I'll switch it on. Oh, it's just wrong. Hey, online guys, can you hear me? Ben, so Ben, can you hear me? Why is the audio not working here? I'm not muted. Ben, you're muted. Ben, you're probably no, Ben. Your audio needs to be switched on or something.
Professor, we can hear you actually.
Yes, we
Brian, can you hear me on your phone, on your computer? Brian, they can.
We can. We can.
Ben is not.
We can hear you.
Okay. No, but I didn't even see his lips moving.
Oh.
Right, so it didn't look like he was answering, and then the chat is empty. So I want to make sure before we start, I want to make sure that everybody is here. Okay, how about Ong is not here today? Roger's here. Yeah, okay, and maybe that's Ong maybe coming here. No, that is Kiera. Okay, yeah, well, okay, Ong's not. Oh no, Ong is here in online. Justin and Dylan, can you guys hear me? Say something, okay? I mean, don't. Where's chat? Okay, we can hear you. Okay, someone did say that. And this one is not switched on. So it's very funny. You can hear me, but you know, I was thinking that you guys couldn't hear me. Okay, here. All right, all right. This is what we're going to do today. Okay, how about we go to that sonnet game that we worked on last class. Okay, it uses vectors. Here's my plan for today. What time is it now? All right, let me make sure that we have enough time to do all the more interesting stuff to come. All right, I'm going to make sure that I'm here, and hopefully everybody can see me. That's much better. All right. Here's what we'll do. We'll take that game that we wrote, sonnet, and I think what we'll do is if someone has a Mac, we can turn that into a Unix command, right? Something I talked about before. Very simple. It's going to take like 10 or 15 minutes. It's just 10 or 15 minutes. But in the process of doing that, I'm just going to talk through the code. And then after the code is there in place, I'll go through the things, code step by step, and I'll say, well, this is what it's doing. Most of the time, I won't have to do that because you'll know what the hell is going on, okay? By the time we talk to you. Is that okay with you? We're going to do that. After that, this is my plan, okay? After we finish writing this Unix command and saying, all right, here we've got a really cool game, we're going to turn that game into something else which uses more features for arrays. Okay, we're still going to use vectors. Okay, and towards the end of the class, I'll say, well, vectors are based on something called a native array, and this is what it is. But really, you don't have to use a native array for a lot of things we do. Okay, but a native array is basically just a bunch of bytes in memory. Okay, so right now you're using vectors. Yes, you're using vectors, which is a vector of strings, a vector of characters, and so on. Yes or no? So far you know how to do that, right? You say vector and then string within angle brackets. Yeah, Caesar. Yeah, okay. So vector and then string within angle brackets gives you a vector, an array of strings. However, there is a difference between using a vector like that and just using a native array like that. Okay, a native array means just give me space for 20 strings. Okay, you can make that call to the C++ compiler and it'll reserve space for 20 strings and it'll give it to you. But technically, is it going to be strings? Well, let's say 10 characters for now, okay, or 10 integers. Let's just say 10 integers, a vector of integers, 10 integers. It'll make that space and give it to you. It's faster, but it'll be on stack. Someone asked a question about stacks and heaps and all. We'll get to this, right? Next week, we're going to talk more about that. But and in fact, when we do that, it may make more sense to talk about the native array, the underlying implementation of vectors. Today, we're going to continue to use vectors, okay? And maybe we'll touch upon what a native array is. And I think we have good time for covering all of that, okay? So we're going to do that. And so here's a plan for today. It says this, I hope this idea works, okay? I think it's really cool. It's the same kind as a sonnet kind of strategy, okay? But we are going to pick a vector of 10 three-digit numbers, okay? So this is the first challenge. How do you write a method that will take a vector and fill it with 10 three-digit numbers? It doesn't, strictly speaking, doesn't have to be three-digit numbers, numbers less than 1,000, okay? So it's gonna be 10 numbers, 10 random numbers less than 1,000. Okay, so here's a plan for the game. First of all, you tell me if this is going to work or not. Okay, and whether it's an exciting and interesting game to do. It has to be exciting and interesting too. Yes. Okay, so you're going to pick random numbers, 10 random numbers. Now, when the game starts, you're going to say, get ready for your 10 numbers. Okay. And then you're going to show, just like you showed the sonnet lines, you're going to show the 10 numbers, format it nicely. Like, you do in get AP terms. Okay. Number with spaces in between. So 10 numbers. You get 5 seconds to look at those numbers. And in your mind, you have to calculate the average before the numbers disappear. Okay. Now, you don't have to get the average exactly correct. Okay. This is a twist from the previous thing, and it's going to introduce new features you're going to try and do here. Okay. You're going to, in your mind, you show the numbers, you're going to make your average guess. Okay. Now, you're going to ask, how many players are there? Or you can say, enter the names of players. You're going to get a loop, okay, and get all the names of these players, right? Spencer, Isidore, Kira, and so on and so forth. You just type in, and you say, well, when you're done with players, just hit enter, right? It's blank. So when you're going to keep reading players in a loop and stuffing them into a vector of players until such time as one of those players has a null name. Yes, so we got the condition to exit the loop. Yes, we're going to do all of this, okay? We're going to do this in code. I'm just giving you an overview, a bird's eye view here, so you don't have to understand all the detail yet, okay? So you're going to, where did I leave off? Yeah, okay, right. You show the numbers. You're going to calculate them. Oh yeah, calculate the average. Calculate the average yourself, okay, of those numbers, and then erase those numbers. Okay, after you erase the numbers, you're going to start entering the player names, and you enter all the player names. Blank. Okay, no player, no more players. Okay, now you got a list of players. Now you're going to get into another set of loops where you're going to say, okay, player number 1, Spencer, what is your best guess for the average of the numbers you saw? Okay, all right, and Spencer's going to enter some number. Maybe it's not the exact average. It's going to enter some number. Okay, and then you're going to go to the next. So this is the overall thing that you're going to implement. Okay, you're going to go to the next player. Okay, and say, okay, Kira, what do you think is the average of these 10 numbers? Okay, and she's going to enter a number. So everybody's going to enter their own guesses. Okay, here the order matters because Spencer could say the average was 97. All right, and in the past, if you look at the Price is Right game, many people will take a shortcut and they won't say the exact thing. Well, Spencer said 97, so let me say 98. Okay, so you're on one side. Okay, so order matters, and it's going to be fun. You can take turns playing this game, but everybody is going to give their guesses. After this is the next challenge, and it's going to be an interesting challenge. You got to find out whose guess is closest to the actual average, okay? Not the actual average. You got to find out whose guess is closest to. How do you do that? Okay, it's an interesting problem, isn't it? It may even be an interesting icebreaker problem in an interview. Yeah, so if you're interviewing someone and you want to make them comfortable and get rolling with warm-up loops and all, you can say, all right, here's a bunch of numbers and here's another random number. How do you find out which number is the closest? Yeah, it's very, very simple, and you're going to do this, obviously, yeah? And there's a number of ways in which you can do that, and we'll do it one way, okay? So you're going to find the number that's closest, and you say, okay, Brian, you won because your guess of 97 is closer to the actual one, which is 96, and the second place winner is maybe Jonah, right? With 104. Okay, so it's going to be fun because it's going to it's an arithmetic game, right? It's not even a math game really, because you're just calculating average like a statistical game, but it's too fun because it's going to exercise some of your quantifier muscles in your brain. Okay, and it's going to say, all right, you got some numbers, you got 5 seconds to find out what the average is, or at least get close enough to the average so you can win the game. Okay, so I think that's enough of the seed of something exciting in here that we can build. Yes, that's all we're going to do, and we want to make it modest so that we don't spill over into multiple classes. I think this is all doable after this. This Menjog game that we implement, the Menjog game, we still have time to finish this and play this game today. I think so. Yes or no? If yeah, I know. Yeah. Okay. So yeah, a couple of thumbs ups. Okay, great. Hey, Ian. All right. So we're going to implement a couple of games today. Okay, Ian. So you should probably sit with one of these guys and you can catch up. Yeah. And so that's our plan for today. Does everybody have a clear understanding of what we're going to do? And otherwise, we'll just start. Yeah. We'll start. How about someone today? So here's what we're going to do. The first thing we're going to do, what time is it? Yeah. The first thing we're going to do today is take that Menjog game, the Sonnet game from before, clean it up and also turn it into a proper Unix command. And in fact, how about, so let's just do it in a terminal setting. Here's the thing, okay? Eventually you're all going to be using IDEs like Xcode, VS Code, many different IDEs, okay? And I've seen people use IDEs and also do really cool stuff with IDEs, but some of them actually don't know the guts of the idea, what actually goes on inside, okay? You just submit a bunch of files and out comes a baby like that, but I think it helps even if you do it only like 5 or 6 times in your life, usually it's more. I think it helps to just go down to the nuts and bolts and actually compile a program just from CPP files, like text files. Yeah, that is what the IDE does, essentially. Most of these IDEs, they're just dealing with text files. You have, .java files, .cpp files, all these things. And they will take these files and remove your headache of saying, well, you know what, I got these files. Now let me check which files are older or newer, right? Which files have been changed since the last time I sucked the binary juice out of them. That's really what they're doing. Yeah, the IDEs have this mechanism to tell, I looked at this file. I already simplified this source file by, compiling it. So compiling it is essentially turning that C++ into machine code. Okay, so it turned it already. Now it's the C file, that program needs to be recompiled because it was part of a bigger package that involves like 10 files. Yeah, so the IDE knows. VS Code, all of these people, even terminal commands like make on Unix, the things they do is essentially look at the file and look at the binary that was generated from them from the file and say, well, this is now newer, so they made some changes, so I'm going to regenerate the binary from here. So all of these painful decisions, when you have 10 files, it's okay, you can do it manually, but sometimes you have projects with hundreds of files. Yeah, so that's when you really need IDEs. But today what we'll do is we're going to go to the painstaking bottom step, and we'll just do, this is going to be one file. I think most probably it's just going to be one file. Okay, so we'll do it with command line. Someone with someone who hasn't coded before. How about someone who hasn't coded before who has a Mac? Okay, someone who hasn't coded before who has a Mac and can run terminal and share your screen. Yeah, if you pick up the screen, I'll walk you through the entire code. Okay, which is first of all, we're going to go to online GDB and pick up the latest version, and then we're going to hack it. And it's going to be a good, fun experience. Okay, I can guarantee it'll be a good, fun experience. And anytime you're uncomfortable, you can hand it over to someone else. Okay, I know there are people here who want to do it too. Like Jonah said, he wanted to do it. I think you wanted to do it, right? So the Unix command.
Oh yeah, I can.
Yeah. So there are people who can have who would like to have fun with it. But I'm thinking that it'll be better if someone who hasn't done it before take a crack at it. Everybody's going to be behind you, okay? And we're going to walk you through this code and step by step so that you understand, everybody understands exactly what the hell is going on. And then there's going to be time for you to create your own versions. I think we'll have time, okay? Create your own versions if necessary before we go on to the next one. And we'll also have time to demonstrate your program to other students. And later on, when we do the other program, we'll have what we did last class, which is you're going to do something and work with someone else in class. Maybe someone sitting next to you or someone out there on the far side of the room, and you're going to exchange and say, hey, you play my game, I'll play your game, and what did you do, and so on and so forth. It doesn't always have to be a demo. You can always work together and have fun too. Okay, so I don't have to be on this side of the screen, and I can just be wandering around with you guys. Oh, this is the online students. Okay, so they can speak up, and then I can come back here. Okay. So I think that's the plan for today. Everybody okay with this? How about someone who has a Mac and who'd like to get on the roller coaster? Okay, it'll feel like I think if you've never coded and shared your screen before, it'll feel like a roller coaster because you're coding and people are looking at the code and all. But very soon you'll just forget it and it'll be fun. Okay, and you'll have a great time. You'll have a great time. And we're going to even if you're stuck typing a single curly brace. And if it's week 5, we're not going to say, hey, you should know this by now. No, right? But we're still going to walk you through this and say, all right, curly brace there, space, enter. So you'll have, someone holding your hand all the way through. And if you already know what the hell is going on, you can also type ahead. Okay. So everybody in class, I think, is comfortable enough with doing that kind of code, and everybody should be. I don't think everybody is, but everybody should be as that comfortable. Okay, so if you're not, it is a great opportunity for you to actually just volunteer. It's actually a very friendly group of students. Okay, very friendly group of students. Everybody is in the same boat, right? Everybody wants to get the same thing out of this class, which is to work on engaging and fun projects that you can also showcase to other your friends and relatives and say, hey, I got something really cool that we did in class. Do you want to play it? You want to try it out? Okay, and in fact, you don't have to show them the code. Actually, that's a cool thing, isn't it? Because you have kids that say, here is the code that I wrote in class. Can you take a look at it? Well, you can actually say, I wrote something. Can you try it out, right? And tell me if it was engaging and fun. And I think that that kind of experience you're already likely to get in CS2A in week 5, which I think is pretty cool. Yeah, so you'll have a lot of scope for you to enjoy this. Okay, so please do volunteer. Okay, someone with a Mac. Spencer, you want to do it? Fantastic. All right. Okay, so Spencer is going to share a screen. So how come the lighting is now? Maybe it was this light here. Okay, maybe I should turn this around. Oh, maybe it is this, right? This is so bright that the backlight. So if I just turn it around like this, yeah, see, there's much more. It's much brighter. Oh, you can't share the screen? Do I need to do something to allow you to share the screen? Hang on. Yeah. Okay. Multiple. All right. Now you should be able to share the screen. Share the screen.
What Reddit group are we supposed to be like that?
All right. So since you're in the Genius Bootcamp, you can actually post in any Reddit. But if it's a quest related problem, or also if you feel that it's, a blue level or green level or red level, right? You'll get much better responses if you post in the corresponding level. Yeah. But because you're in the Genius Bootcamp, you can post anywhere. The bootcamper can post anywhere, essentially. Yeah. But no, Reddit, I'm just using the bootcamp for both the, the Reddit for both the bootcamp and the class. It's exactly the same because they can help each other.
Because I don't see many people posting the quest.
Yeah. That's what I mean. People should be posting more. People should be posting more. You shouldn't be, the questing is not any of these things, even applies to other computer science classes that I'm not involved in. Okay, maybe you're doing computer science or math classes with other people. Many of this is supposed to be group activity in the sense that, it's not like get this answers from other people, but it's supposed to be worked in a group and sharing interesting things with other people. And so you should be interacting. By the way, this thing here, this entire series, CS2A, 2B, 2C, what you get out of this class or this entire sequence is not the paper qualification. Okay, it's not anything that I tell you. All of this will be forgotten. What you really get out of it is what you learn, these tricks and techniques. But so I think that I was actually going somewhere else with that thought, but I actually I forgot. But you should totally take advantage of this opportunity. Oh yeah, what you get out of it, I got back on the train after. What you get out of it is your Reddit profile. Okay, so you got a chance for 3 quarters starting now. This is your 2A, 3 quarters of time to build up an incredible profile on Reddit, so that if someone says later on, this is a student, or this is an employee, that or a potential employee applicant, all I need to do is click on it and look at what they've done, and that saves 99% of my interview generally, because I can get a 360 view of exactly what the hell you're doing, whether you know your stuff or not. All of that is apparent. Not right now, but when you get to the Reddit, all of that is really very clear. So and so for a hiring manager, that is like a gold mine. And so that is, and I think if you recognize that when you're in 2A itself, you have an incredible opportunity to build up this profile. So that is what you get out of the class. For $150 or 3 times, right? 2A, 2B, 2C, $450. What do you get? The transcript is, I don't know. It's not as useful. Yeah. Right. However, if you use that time to build up this killer profile, that'll be worth like millions of dollars in the future. Right? Because you will be sought after. You can use that as leverage to get a better pay. But you should take advantage of these things, because, thinking that I'm going to, graduate from college and then build my Reddit profile, right? Or, build my, Stack Overflow and things like that. Not a good idea, right? Because then you'll be under stress. You'll be doing something because you have to do it, right? When you do something because you have to do it, because you're forced, because you're, you're looking for validation from outside saying, oh, that's a really cool post. That guy must be cool. And you're actually beholden to it and looking for it. It's not going to be as good quality, I think, right? So because it'll be the best quality you can make if you're doing it for just the pleasure of finding out what the hell is going on, right? Because you're never going to stop at some, shit ass answer that says, it gives you a high level overview of what the hell is going on. Yeah, you're not going to be happy with that. So you'll actually be looking for the core truth everywhere. And that's why being a student here and making these posts is like super duper important. Actually, I was talking about, this with my son earlier today in the car, buzzwords and all. And I think it was an interesting point that I want to make. And I told him that I want to tell my students also. Especially in the Silicon Valley, this buzzword thing that people like to use the in thing in their conversations. And so I see a lot of people, you're talking about ChatGPT and, the thing of the flavor of the day, but today it's ChatGPT and language models. And they say, I'm using ChatGPT for this and building a platform with ChatGPT, doing that and so on and so forth. I say, as far as when people come and talk to me about this, I've had some people say, I'm doing this with ChatGPT because I try to invest in these things, and sometimes they give me business plans and say, this is a pitch, are you interested in funding in this idea? So a seed in this idea. So I say, well, fortunately, I've been doing language models for a very long time, back at SRI and all. So and when someone talks about ChatGPT and building a language model based application, the first thing I want to know is not whether they can just put things together. Because people have been doing that for a long time, putting things together, internet and so on and so forth, computer, new applications being created. Yeah, that's not the thing that most heavy duty software powerhouses are looking for, right? They're looking for a real core understanding of the data or the way. So the way that someone says, I'm using ChatGPT for this, the right questions to ask really is, what underlying model are you using? Are you using a neural network or a statistical model? Now, if someone says I'm using a neural network because, as I've done some empirical tests and I found that this is better, right? Then this natural question is, what I look for as an advisor or an investor is not someone who knows how to use it, but even if you're using a neural network model, do you know how to build a statistical model first? Because even if a statistical model is key to be, you have to understand something before you go on to something that emulates that much better even. Right, so they need to know, about back-off weights in language models, how you interpolate language models, how can you use the EM algorithm to find the optimum weights for interpolating language models, right? Do you use Witten-Bell smoothing or Kneser smoothing, right? And under what conditions? And if the data stream is not pure text tokens, which you'll actually be doing later on in this class, maybe in 2B, maybe in extra credit, you'll actually be doing work in building a small language model where you have streams of tokens coming in. That'll be a text language model, right? Because you're just dealing with text tokens. But there's no necessity that you only have to use text tokens in building a sequence, right? A sequence is just a predictable sequence. So the text tokens can be anything, but you need to know. Yeah, well, are you pre-processing the data to change some of the tokens that indicate actions? And what is the basis for those changes? So all of those details need to be got into, and that's why the devil is always in the detail. And I say that a high-level explanation of saying, well, I'm using this and it works. That's like a child explaining how the radio works. Okay, well, well, there's an empirical basis for this. I understand there's an empirical basis. Yeah, okay, well, that means you're just a follower of science. Saying, well, what, empirically it should be true, but I don't know how the hell it works, okay? But I believe that it's empirical. There's no supernatural power involved there. But that is not real scientific mindset, in my opinion, right? Scientific mindset, okay, well, it's empirical, but I also need to know how it is empirical. So you need to go into the detail. And so with all these algorithms and all these things too, it's not just enough to have a hand-wavy explanation at a high level, saying if I feed this in this format, I get that output. Okay, that is what a neural net does essentially, right? It's a black box. So and what we want to do in this class all the way through in the sequence is you're going to go all the way through to the nuts and bolts. Where in Quicksort, for example, this is 10 lines in question number 7. It's just 10 lines of code. Chris can correct me if I'm wrong. This is less than 10 lines of code, but you'll spend a lot of time just refining those 10 lines, squeezing cycles out of it, not with a view to make it more efficient, but the point of squeezing cycles out of 10 lines of code is to figure out computational thinking, right? To say, well, if I was a true computer scientist, this is what I would do. And you distill it out and you actually get that feeling. Right now, I can't get any better than this, and you find one more way to get better after that, right? And so all of those, things are in the detail, and you won't find it because I could explain Quicksort even when I was an undergrad student when I didn't understand Quicksort. Yeah, I knew it would work, and I could use the library, and I could also do the hand wavy thing, right? Split into bam bam like that. But until I actually implemented that, and late in my undergrad work, actually, I actually didn't have an appreciation for exactly why these things are done, even the different ways of partitioning things. You'll get a chance to do all of that. And this class, this series will be an opportunity for you to build up this entire profile on Reddit. So don't let go of that. Hopefully, I don't have to talk about that more. But Reddit is your friend, okay? It's not just because it's for this class. Use it as your friend, leverage for your future, okay? And I think that is the right approach. So yeah, please keep it more lively and active. Thank you very much. Okay. All right. So Spencer, now you can share your screen. Yes. Great. So let's go to your terminal. Just go to terminal. Let's not use Xcode for now. Yeah. Let's go to your terminal. Okay, and maximize the window so the rest of it is kind of, yeah. Can you increase the font size, Command plus or something like that? I know that's good enough. That's good enough. Okay. All right. So now you want to go to that. This is your home. Is your home directory?
No, this is the directory for the file I brought up.
I see. Okay. Let's just create a temporary directory and put everything in there now. There's only one file, and you can compile it into a binary. Just one file, and then later on we'll, you can organize it differently if you want. Okay, it's just one file. Just make a directory, get into that, right? On Linux, Mac, all these terminals, the way to make a directory is mkdir. Okay, mkdir. In fact, what we'll do is make it on your desktop so you won't forget it. Okay, otherwise it'll be trash in this inside directory. So all right, so mkdir. Okay, mkdir. These, if you have a Mac, these are all tips, okay, right? And then say tilde. That is the shortcut in Unix and Linux like systems for your home directory, okay? And the desktop is basically just a directory in your home directory. So yeah, capital D and then desk and then tab, yeah, right? So auto completed. So it'll just go to desktop. All right. Now make there after desktop say slash and say what do we call it? Menjog. Okay, just call it menjog for now. Menjog. Okay, that's the name of our game, right? Yeah, enter. Now you want to change into that directory, and the command to change into the directory, I think it's CD or chdir. Try one of those. Yeah, CD. Great, thank you. Right, so you just change the directory. I want to look at the contents of this directory. What's in this directory, right? There's a command called ls, okay? And you will call it with a flag, which modifies its behavior, saying, give me all of the files in there, right? LSA, and give me a long listing. Tell me, if there are any files and what the size is and so on, right? So type ls space dash la, right? And I'll show you just two dots, right? That's the current directory dot and the parent directory dot. Okay, so we're not concerned about those things. We're going to create the file here. Now let's go to that tab on online GDB, where who posted the last link? Ben or someone, right? This is the link to the code, Sonnet game. Someone posted the link to the Sonnet game. Where is it? Ian? Ian? Who posted last class? I think it was Ben.
I think I posted it, yeah. In the Reddit.
Oh, it was in the chat. No, I think it was in Reddit.
Yeah, I posted it in Reddit.
Sonnet.
Anybody did last class, but that was the one writing the code and editing.
Can you post it now? Yeah. I see. Otherwise we'll just do it from scratch. I think it's okay. If we do it from scratch, I won't be talking about any of this. I'll just, we'll just rip through it and get it back, right? I can just read it off from memory. So basically what we want is that as soon as he, Jonah shares that link, grab that entire code and put it in a file in here, and that's what we're going to work with. Yeah.
Because the thing is that I made like my own version.
We can hack it. Yeah. All right.
But also the changes I made aren't finished.
Oh, I see. Okay. If you're okay with it, you can share it. How about we just do it from scratch? Okay, it's not a big deal. All right, let's do it from scratch. Let's do it from scratch. Okay. So what kind of editor, text editor do you have on this machine? VI, Emacs, Pico, one of those things, right? But yeah, if you know, do you know how to use Pico? I don't know how to use Pico. Try Emacs. Just type Emacs and hit return. No, not Pico, because I don't. Oh, all right, we could try this, but I don't know. Are there any Pico experts in this class, or at least know how to? Nano is, you've used Nano.
Yeah, well, I use it on my computer.
Yeah. Okay. All right. So if we get stuck, we can ask Jonah. All right. So how about we start with the standard template, which is, hash include IOStream, and we're going to use hash include vector. Okay. Hash include. Now we're going to do this fast because it's code that we've already done. And so we're not going to belabor many of these things. Okay. Yeah. Hash include vector. If any of you are stuck here yeah, you should ask. Okay. You should ask, and then we can. All right. Great. Oh yeah. It's stream, right? Not game, Steam. All right. Okay. Using namespace. Okay. Using namespace standard. And then what did we have? You can put a blank line above that. And I think we had after that. So this was a Sonnet game. Oh, I see. We need to get the Sonnet and all. Can you at least paste the Sonnet?
Yeah.
Yeah. You can actually paste it in chat, and then he can grab it from there. In fact, the vector, not just the sonnet, just the vector. Right. So do your main, and then we'll do the rest of it. Okay. So let's come. Yeah. Enter. 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 Yeah. Yeah. I think you can go one level up and say int main. Yeah. Even one more blank line, but that's fine. Okay. Int main. Here we're going to say int argc. Okay. Int argc. Argc. Okay. So it's two parameters that you will see in quest number 3, 4. Limerick or something like that. So argc is a parameter that is given to you. So C++, as you know already, is all driven by functions. Yes, we call a function and the function does something. Call a function and that function can call more functions. However, there's one function you don't call that starts the whole program off, right? It is main. So main is also a function, but you don't get to technically you can call main, but you know, no programmer that's in mind does that. But main is also a function. You can call it. However, it's called the entry point, and the operating system knows when Spencer's program is run. In that program, I'm going to look for a function called main, and that is where I'm going to start my execution. Okay, so main is called the entry point. Okay, however, it gives you some niceties on top of that. Okay, I'm not only going to invoke the program when someone says, you know, run menjog, and here are some parameters, command line parameters to this function. Right now, actually hit Command Z for a second. Control Z, Control Z, Control Z. Oh, it doesn't do that. Oh, another tab. Command T to another tab on your terminal. Another tab in your terminal. And Command T should give you another tab. No. Oh, I see. Pico's catching all of those. Taking over. So how do you get out of this? How do you get to run? I've actually forgotten what I was going to do. And then you get out of it. Yeah, all right. So I see. Oh, and then you have to get back into it. You know, it is really unfriendly. Yeah. Okay. Yeah. It comes with the operating system, I guess. VI is better. In fact, we should use VI because at least I know how to get around with VI. So type VI. Oh, did you exit it? You didn't save it at all? Okay. So VI the file. VI or VIM. Yeah. And then you can hit tab. There's only one file. No, I think it's called menjog. Oh, you call it sonnet.cpp? I thought you called it menjog. Can you rename it to rename it to menjog.cpp, because that's going to be a program. Yeah. And I'm saying, it's going to be nice. Okay. There is something there. You'll understand why. Okay. Rename it to menjog.cpp. All right. Rename it. So mv, right? Sonnet.cpp to menjog.cpp. All right. Menjog.cpp. All right. Now you want to vi menjog.cpp vi. Now this is all terminal based stuff, is not directly relevant to CS2A, but I think it is useful and cool. That is why we're going through this. Otherwise, we could just do the whole thing in online GDB. But I think this is fun. Okay, so if this is not relevant and you guys are bored, let me know, and we'll skip the stuff. I just think it is useful for you to know anyway, because right. So let me know. It's okay if you're bored. Okay, so don't. Right. So this is VI, right? Now this, I'm pretty sure you can do Control Z out of this. Control Z. Oh, even VI doesn't do it. Only Emacs honors a Control Z. That is so funny. All right. So what I wanted to show you was, but this is not the file. Oh yeah, I see. You can't get another tab. In fact, get out of this, open another tab. I just wanted to command terminal so that I can show echo ABC, and then A, B, and C are command argc of 1, 2, and 3. I wanted to show you what that is, but we can skip the demo. All right, so that's fine. VIM will do that. They are probably the same thing. That is fine. You don't worry about it. Okay. So argc, and then the next one is char, char. Yeah, no, don't say star. It's char. All right, so say char, and put a space before the star. Yeah, and then say argv, all right, argv, and then square brackets, open and close. Okay, now talk about native arrays. Argv is a native array. Now the operating system, when you give it command, when you call a command on the command line and give it parameters on the command line. Someone has a question? All right. Okay, yeah, so the command line parameters are actually supplied to main by the operating system. When the operating system forks off your program and say, hey, run Spencer's program, here are some command line parameters that the person running the program supplied. Okay, and they come in argv, which is a vector, a strong is an array, a native array of strings, right, character arrays that we can grab. And argc is a count, the number of parameters that were given to us, right? We'll get this. Okay, so in fact we'll do a demo, right? So here let's just do a loop right here, just do a loop, right? Indent in. Wow, it's 8 spaces, right? So say for size t I equals 0, for size t I equals, this is all a demo, and it's also practice in using loops. You should also be doing this later. Okay, for size t I equals 0, I less than argc, right? I less than argc. Yeah, and put spaces around the operators, so it's I less than argc. Yeah. Now and then at the end, yes, semicolon argc I plus plus, and put an semicolon, space after the semicolons too. It's nicer. Spaces after the semicolon, not the space at the end. Yeah. All right. So on the next line, you're just going to say cout. Yeah, tab in one more time. One. Yeah. All right. You want braces? You don't need braces because there's only going to be one cout, right? So yeah, right. Cout, left shift. And then as a string, you're going to say argv as a string, right? Argv. Also spaces on both sides of the operator. Yeah. Oh, well, at least one side. Okay. No, that's a argv is a string. Okay. Start a string, and you'll see what this is, right? Right. And then square bracket, square bracket. Now I'm actually constructing what the UI will actually output here, right? And you can play this in your head, and you can do this yourself too. No, only one, not two, right? All right. Now after that, left shift I. Okay, left shift I. Yeah, and spaces on both sides too. I will be nicer. Yeah, and yeah, this was all right. Now left shift the closing square bracket. Okay, left shift the closing square bracket. Does everybody see where we're going with this? We're just creating a program, not yet Sonnet, right? We're creating a program that is going to demonstrate argc and argv. When we run this, it's just going to print these are the arguments, and that was given to, right? So you'll know exactly what's going on. Now after the square bracket, put space and equals, space equals. After the square bracket, yeah, space equals, and one more, yeah, all right. Now left shift argv square bracket I. Okay, left shift. Argv square bracket I, all right? Argv square bracket I, which is the ith index of the vector that is passed into us, right? It's not a vector, it's a native array, C++, right? Argv of I and end L. That's it, right? Now, yeah, that's it. And return 0 at the very end of main, right? Return 0. Now, this is a complete program, return 0, okay? And one blank line above that, yeah? So that it's. All right. Now we want to save this. Escape colon WQ, right? Escape colon WQ. Is this Pico? Oh, it is Pico. I thought you were in BI. So Control X, Control S, I think. Control S to save. Oh, Control X and Control S, is it?
Control S first to save it.
To exit. All right. So it didn't save it. Control S to save. Yes. No, did you say yes? Control S and then right. Now we got this file called menjog.cpp that Spencer created. Let's make sure it's there. ls-l, right? Up arrow until you get the ls-l. Yeah. There you go. It's there. Okay. I don't know what the .swp is. It's created something else. There's this file called menjog.cpp Spencer that created. We're going to see what is that file. What does it contain? So you can say there's a command called cat. Concatenate is shortened to cat space menjog.cpp. Cat space menjog.cpp. Right, and hit enter, and you should see whatever Spencer put in the file. Right? Everybody okay so far? We just use an editor to create this file. Now we're going to compile this file and create a binary. Okay. Now here's the cool thing. No. Here's the cool thing. Okay. Just type make menjog. Okay. And that is why I went through the extra trouble of name the file menjog. Okay. Now there is a program called make. It's an ancient version control system. Okay. Before IDEs and all. Make knows that it's got rules built in. and says, oh, you want a program called menjog, but there's only menjog.cpp. But I know that if I compile a CPP file, I can get an executable. Make knows that, okay? So if you type make menjog, it'll actually compile it for you. There you go. Okay. And the compiler on this machine is actually C++ and make things at C++. And they're probably an alias to G++. Okay. So it's compiled it. Now menjog has been created. Now we're going to run this command. Okay. And for running the command, you're going to say ./menjog, ./menjog. Okay. And give it a bunch of arguments. Okay. Say space Spencer, space Brian, I don't know, space, Vivian. Okay. Yeah. All right. Now if he hits enter, you will see exactly what argc and argv are. Very common question. Lots of people ask this in the forums, especially when they come to question number 3. Okay, you'll see the answer. You see argv of 0 is the word menjog, the name of the command itself. argv of 1, the first element of the array, is a string that is Spencer, Brian, and Vivian. All right, so we get this passed into us. Now we're going to make use of that in the game. That's all. Okay, so is so far everybody okay? Everybody understand what argv and argc do? They just counts and parameters passed into us by the operating system. Okay, so now you can go back into the file. We'll try and edit it. Okay, now you can get rid of argc and the for loop and all. And what we want to do is basically recreate that file. And so what did we do? Yeah, we need the vector, right? Copy and paste. Oh, here I think you can actually do a uppercase D. It'll get rid of the whole line, but that's okay. Oh, this is Pico. Command Control K could get rid of the whole thing in Pico. Yeah. Jonah? The whole line. Never mind. Okay. All right. So here, get the vector that Jonah posted in chat. Okay. And put it there. All right. That's our vector, and it's going to be in main. It's in the chat. Okay. If you go to chat, Jonah posted a vector. Where is it? I don't see it. Oh, here. Why is the font so weird? So big in here. Okay, anyway, copy this. Yeah, copy this thing. Yeah, you put it there. Okay, great. Okay, so we got the vector. And then you can say, instead of sonnet, you can call it default sonnet. Okay, default sonnet. Default underscore sonnet. Okay, now here's the thing we're going to do. Right now, after, oh yeah, you want to indent all of that in. Can you select that and push it in? Yeah, just indent one. Yeah, there you go. Thank you. Right now, after that, that's a default sonnet. Now, what we want to do is create a vector of string called sonnet. And in fact, yeah, I think that's what we'll do. Right. So, and here's the bit where you have to ask me if you don't understand anything. Okay. So here, and also, yeah, that also. Great. Okay. Now, blank line after that. Yeah. One more blank line. One more blank line. Okay, here we go. Right now, what we're going to do is actually check if the count of the arguments that was passed to us is greater than 1. Okay, if it's greater than 1, the command was called with the word, Spencer. If it was not called with Spencer, you'll see that, argv of 0 is menjog, and that's it. Yes. If argc is greater than 1, then you get the second parameter. So one way for us to determine if a second parameter was given to us, or the parameter was given to us, is just check the value of argc. All right. So here, yeah, argc is greater than 1, and we'll put a comment there because for people who are not familiar with this, put a comment on the same line as argc greater than 1, and in space curly brace, space curly brace. But put a space curly brace also, right? I see you want to put it there. Okay. Yeah. All right. So, but put a comment on add the comment and say if the program was invoked, with a command line parameter. That's what it means. Okay. All right. So if it was invoked with in fact, what we want to do is we want a bigger comment. Take that whole comment and put it above the if line. Okay. So we're going to flesh it out a bit more. Thank you. I think Control K and Control Y may work. Okay. Hit Control K. It didn't work. Wait, oh my gosh, something happened there. All right, so yeah, there, Control K. It didn't. All right, we need that on the previous line. Get rid of that argc thing. In front. If get rid of the if statement, we'll type it in again. Yeah. Right. So if program was invoked with a command line parameter, then we want to try to fill our vector with lines from a file named by argv of 1. Okay. No, no, no. We want to continue the comment so that we tell students what we're doing. Yeah. So on the next line, you can say if the program was invoked with a command line parameter, right? This is the Unix idiom, right? That's all. That's just that part. Okay. And you can hit enter. Oh yeah, yeah. And then continue the comment one more. Yeah. Then we change. Then we use the lines from a file named by the first by the parameter. Then we use the lines from a file named by that parameter. So far, is that clear? That's what we're going to do in that if statement. That's what we're going to do. Yeah. Okay. All right. So here, so inside of the if statement, here's what we're going to do. It was given a parameter, so we can forget about the default sonnet. Okay. So we're going to say default sonnet dot clear. In fact, just call it sonnet. Okay. Forget about default sonnet for now. I'm sorry about that. Yeah, just call it sonnet. It's a sonnet dot clear. That is a command for the vector class to say you got some strings in there, just clear all of them, release the memory. So the vector is now empty after the clear. Okay, so you can say sonnet dot clear. Okay, sonnet dot clear. Okay, open close. That's it. Okay, that'll empty the vector. You can put a comment there saying that should empty the vector. That should empty the existing vector. Right? Put a comment saying empty the existing vector. Right? So now we need to try to open the file and read lines from that file into this vector. Yeah. So how are we going to do that? So one way to do that is to use ifstream. Ifstream is a library. So the file stream, there's a file stream library, and there's an include file that you can put at the top that says, well, you know what? Now you can also use file stream. This is what we were talking about before. It's in the CID, but it's not in syllabus. I'm going to walk you through that now. So yeah, right at the top, after IOStream, not before vector. After IOStream, before vector, say hash include fstream. Okay, fstream. It's a file stream. And then put a blank line after that because vector is different in character. Yeah, all right. So, and there's 2 blank lines there. Yeah, thank you. And there's 2 blank lines after namespace also. Right, great. All right, now sonnet.clear clears that. Where are we going with that? Fstream. All right. Now what we want to do is say ifstream, open, ifstream, and we need a name for this variable. So we're going to create a variable whose type is input file stream, ifstream. The type is just like vector. It's been created for us. It's there in the library. And we're saying we want a variable which is not an integer, not a character, not a string, new type of variable, and this type is ifstream. It's an input file stream. It's right. It's there in the library. You'll see this. Okay. So ifstream. You want to call it in file? Okay. In file. Yeah, I guess it's okay to call it a file. I was thinking file stream, but okay. In file. Open parentheses. And you want to say argv square bracket 1. Okay. That is the name of the first file that's come to us on the command line, and we'll make this more clear by close that. No. Oh, I see. Yeah, that's fine. What we'll do is let's make it very clear. Go above that line, and hit enter one more time. Yeah, and see out, and you can comment this out later on. Okay, and say reading in lines. Reading in sonnet lines, or reading in poem lines, or reading, I don't know, just say lines. Reading in lines from space, close the quote, and then left shift argv of 1, right? Left shift argv of 1, and then endl. Argv of 1, and then endl, left shift. Everybody okay with what we're doing so far? Yeah, idiomatic stuff. So you can just get used to this, right? So enter. All right. So now we open that. Now what we want to do is while on the next line, now everything is going to be so familiar now. Okay, what we do now, everything is going to be familiar. Okay, so while open parentheses, right? You're going to say get line, open parentheses, say in file. That's what you called it, in file. Yeah, in file, comma, and then you want to say you want a variable called line. Okay, so above sonnet.clear, let's create a variable. Right after the curly brace, hit enter. Yeah, and then say string line. Okay, string line, semicolon and enter, so that it's declaration and yeah. So you can declare variables anywhere inside a block. You can people generally tend to group them at the top of the program and so on, but you can technically declare variables anywhere. Yeah. Okay, put a blank line after string line too, so that it's separated. Yeah, is that the right order? No, I think it is cin comma line. Okay, so the line has to be the second parameter. Yeah, hit enter. No, hit. Yeah, you were at the right place to hit enter. Yeah, right. Now I think line has to be the second parameter. not the first parameter for getLine. And also, let's call it FIN so that people can relate it more to CIN. Instead of in file, let's call it FIN. Right. So I think some of the students may think, oh, FIN, it's similar to CIN, so I can use it everywhere that I've used CIN before. I think it's more intuitive for some students. If any of this is confusing or boring to you, you should let me know. Okay, I just don't want to be going on and on with losing you guys. I want all of you to stay with me all the way through. Yes or no? Yeah, online too. Please speak up, okay? Please speak up. I just don't want to be marching on and on, okay? So FIN, line, FIN, line. In fact, after doing this fragment, I'm going to pause and make sure that everybody understands. I'm going to ask everybody, all right? So, right, so, and I think that's it, right? That's what you do. Get line, CIN, line. That's all we do, yes? Right, so after that, we say a curly brace, yeah, open curly brace, yeah, all right, good. Right, now indent in, and you're going to say sonnet dot push back, okay? Push underscore back. Now push underscore back. That is a function that is attached to the vector class. When you use a vector of, vector of integers, you'll probably get an empty vector of integers. But you got like 15 integers to push into it. How do you do it? So you say, all right, here's an empty vector, push back 5, push back 7, push back 10. So push back is the way that you push things onto the end of the vector. Now push back is a good function to know, because there are things that you can do with a vector that you'll see that inexperienced programmers or people with a non-CS mindset will do, like pushing onto the front of a vector, expensive, okay? Because when you push onto the front of a vector, you got to shift all these guys out. If a vector already has 1 million guys, you got to push all these guys. It's like Hilbert's Hotel. How many of you know about Hilbert's Hotel and discrete math? Yeah. Okay. Juliana, you're doing discrete math. Yes. Okay. So it's a hotel with infinite rooms and all of the rooms are full. And a new guest comes along, right? But you can still find room for that new guest who came in, even though all the rooms are full. Because all you have to say is everybody in room number N goes to room number N plus 1. Okay. And then the room number 1 will be free after that. So you can always fit a new person in, even though the infinite hotel is already full. Yeah, so like that. Where are we going? Yeah, vector, right? So a vector, if you want to push something to the beginning, push these guys back. Now you will realize right now, it may seem like, yeah, okay, I can do that too, all right? But when you get to heavy duty C++ programming, this will be in the forefront of your mind, okay? If it's not, you haven't practiced enough. That is the plain truth. So when you're working with vectors, you have to be like constantly in tune with which end and what the complexities are, right? If you need to get to any random place, this is what I have to do. And if I want to push an element in, this is the least expensive way to do it. There are standard ways to do these things. Okay, standard C++ idioms, you'll uncover these and get used to these just with practice. And once you're practiced, you'll automatically know. Then that is when you can start using vectors. Okay, until then you're not really using vectors. Where you use vectors when you know how to use the vectors. So you got to use it many times so that you know ins and outs. Okay, so pushback is a cheap operation and is a good operation to know because it always pushes to the end of the vector, and that is constant in time. You don't have to move any elements. Okay, super duper amazing. They say that you got to say that many times to yourself. Don't have to move any elements, whether it's a vector or a list. Any complex data structure you create, that is the first question that you should ask always. Do I have to move things? Does this come and go? Or, when it comes and goes, other things have happened here, all right? That is always a pain, isn't it? So everything should just be like, a bird in air, no footprints. and so that is what we're going for. Pushback is a good operation that way. So yeah, Akash, yes.
So if you're clearing the sonnet with the dot clear, when you're pushing it back, there's nothing for it to push back, right?
Yes, it'll go on the first element. Yeah, so that is the beauty of pushback. You can push back on starting from a very, from an empty vector. It'll go on to the first element. The first element is vector element of 0, sonnet of 0. Yeah. Okay. All right. Now, in fact, what you can do, Spencer, you can get rid of the curly brace because there's only one line for this while loop. You can get rid of the curly brace. Yeah. Now we'll send some feedback information back to the user. Okay. So on the next line, after the while loop, you can say C out. Red space, close the quote, and then left shift, sonnet dot size. Okay, sonnet dot size, and then lines within quotes. Yeah, and endl. What does it do? It's read a bunch of lines from the vector, from the file and is actually going to say, I write 15 lines, I write 10 lines. Just give some feedback to the user. Now, one of the things that many users like is unless, here's the thing, okay? You're going to be designing user interfaces, programs later on in the future, right? When you write programs, unless you're like cocksure that it's going to work, 100% sure it's going to work, then you can do it the Unix way, saying, I'm not going to say anything unless it, unless it fails, okay? But if you have even the smallest DX% that it's not going to work, there's some weird shit going to happen and my program is going to crash, you got to make sure that the user knows or what you're doing, because you're not doing something that is foolproof. Something could break and go wrong. So you need to lead the user with you. And so verbosity is something that is a very carefully and wisely used feature in all of your programs, and you have to get better and better at using it and when to use it. So many times as people get expert in using a program, verbosity is a pain because they don't want to see a lot of messages. So many times when you write Unix programs, you also put a flag saying, you know, by default the program is not verbose, but if you want it to be verbose, you say -v, and then it'll give you a lot of extra information, right? But right now we're not honoring those things, okay? We just say it's just going to be verbose. That's why he's doing these C outs here. Everybody okay with this so far? Yeah, everybody online? Everybody okay with this? All right, so all right, now in fact what we can do is, you know, close the if thing there, close the if statement, right? Now what we can do is actually compile it and run it with a file, and that will and it'll tell us how many lines were in the file, because it's going to read those files into a vector and tells us, you know, that many lines. Yeah, okay, so now save it, yeah, and exit. All right, now up arrow until you get make menjog, right? Enter. Oh, I see. Hang on. What? Oh, it doesn't have. Oh, no. Yeah. You can just hit enter. Oh, you want to do that? No, it's still giving that error. And that is a really strange error. Sonnet.pushback is not. Oh, pushback doesn't have an argument. Oh, we didn't give it an argument. I'm so sorry. Okay, guys, go back into the file. Yeah. So unfortunately, you guys didn't have a chance to correct me here because it's a new concept. We're talking about vectors, and I completely forgot something that. So pushback needs to get that line as an argument. I forgot that, and that is why it's complaining. It says, I know about a function called pushback that's attached to a vector, and that function takes a parameter. But you're calling a function that doesn't take a parameter, so it must be something else. That's what it's telling me. Okay, so I cannot find a function called pushback because you're still getting that error. Hang on. Well, no, we need to get to the beginning of the error. Now, what was the first error message? Can you scroll up in the terminal to see what the first error message was? No, so sometimes when you come play with C++ code, you get copious amounts of error, like pages and pages. One of the things that CS2A students especially have to get used to is that tons of pages of errors, perfectly normal, not to get intimidated by them. Okay, because usually even simple things like missing semicolons will give you lots and lots of errors, and lots of C++ students in the CS2A get scared off by it and say, well, I'm not going near this because it's, spits out so much nonsense. Okay, most of the time you just go to the first two lines, it'll tell you what it is. Otherwise, make some changes, recompile, and you'll undefined symbols. Okay, no, further up, I think further up a little bit more. Oh, I see, undefined symbols. Oh, no, hang on, use reference from. Okay, and it's all right. Get location, add array, new length. Oh, hang on. Oh, it's me. Can you copy the whole thing and put it in online GDB and let's run it there and compile it? We'll just see what's going on, right? Maybe it's something to do with this compiler. Just copy that program, copy that entire program. Yeah, copy the whole thing, Command A, copy it, go to online GDB, compile it and run it there. Because so far we don't need. Yeah, the online GDB, it'll compile and run, right? We're not giving it parameters here. Oh, this is a bummer. I didn't expect. Yeah, go to online GDB. Oh, share the screen too. Share the screen so we can see. In the meantime, right, while he's doing that, if someone can figure out why the hell are we getting this error, because everything seems like totally kosher to me in that program. There you go. Command A and paste everything and run it. Yeah, Command A, paste it, select the language to C++. No, Command A and paste. You want to put that? Oh, how come it got all the junk too? Get rid of everything, including the header, top comments, all the way up to main. Yeah. Okay. All right. All right, select the language, Oh, why it's just, yeah, get rid of all of that. Get rid of all of that. All right, great. Okay, now select the language, C++20, is it? All right, compile it and run it. We'll see if it actually runs. Okay. We want to see if it generates the same kinds of errors here. Oh, it's put some funny characters here. Oh, see, it's Pico, Control G, when he typed Control G, it just put it there in the file. How do you get rid of it? Oh, that stuff. All right. Oh, you copied the screen. That's why. Okay, all right. So it actually compiled and worked. So there was something funny with the compiler setup you've got. It's not recognizing vector. Yeah, actually, well, if Spencer, if that's okay with you, because this is the first part, we can come back to you for the other program that we need to run. We can go to Jonah. You can share your screen and all, right, Jonah?
Yeah, well, yeah, I can. I just want to see if it works on my computer.
Okay, it'll work if you've got a Linux PC for sure. I'm pretty sure. Okay, so hey, Spencer, can we go to Jonah and come back to you later? Yeah, so just you got an online GDB, just give him the share link and he'll pick it up from there.
Is online GDB based on Linux?
I'm pretty sure it's some kind of Docker container running a Linux box. Yeah. It's really funny. And you did specify the C++ flags and all, and it still couldn't recognize that. Maybe I think it is because Pico probably inserted some funny characters that's not visible. Maybe it is not pushback, it's pushback Control G, and you can't see the Control G. So that's happened to me with even with Xcode. It's even happened to me with Xcode because usually I'm typing Emacs, and Emacs is Control S for saving, Control X, Control S. And in Xcode, I type Control X, Control S. You can't see it, but it's there. And then I compile it, it doesn't compile because there's an invisible character in there. Right. So I've been bitten by that bug several times with Xcode. So it's possible. That's what's going on, especially since, right. So you got it, Jonah? You got it?
Yeah.
All right. So yeah, so you can share the screen whenever you're ready, and then we'll go from there. And then Spencer will come back to you, right? And in the meanwhile, later on today, when you have time, or maybe you can ask if your dad knows also to get the compiler settings figured out on this machine, so that next class on if you're going to type again, we can just go straight to the C++ compiler and it'll go. Right? Basically, you want to make sure that you can get vectors to work, pushback and everything to work. Also, you can install Emacs, which is a really cool editor. You have to install it, but it is a cool editor and it's good to know because some of the hotkeys that Emacs uses are also used by all the shells in many of the Unix flavors.
Okay, here's my terminal.
Great, thank you.
So I have.
Oh, you're funny. You can share it as well as Spencer. Both of you are sharing at the same time. Yeah, I think so. That's Spencer's screen behind you.
I know that's just a different portion of my screen.
Oh, is it? I see. Okay.
I don't know why it's the outside.
All right. Okay. No worries. Okay. So let's go create a. Oh, you got a directory. Okay. Put everything in here and just do. All right. So just say make menjog and hit return, and then let's see if the default is okay. Yeah, hit return. Actually, wait. Okay, so his default G++ is actually able to grok this. Okay, so it works. Now you can say, you can type menjog, menjog, and then say, Spencer space Jonah. No. So just say Spencer.txt. Now it will not say, well, you know what? In our file, we haven't got anything else. If argc is greater than 1, it does this. But if the file is not able to be opened, it won't do anything. What we need to do. All right, so it is trying to read from Spencer.txt. It was unsuccessful and it read 0 lines. But technically, you actually get an error message. When you try to read from that, you will actually get an error message. You can report a message. If you're interested later on, you can find out, say, well, that file, I tried to open it, it didn't even exist. You can get that kind of message, right? Now, what we're going to do is, yeah, there you go. Thank you so much. You can actually reduce the font size a little bit more so that we can get more of the code in there. No, not so much. I just one more, yeah, one more increase. No, font size, one more increase. Command Control plus. Oh, Command plus or oh, it doesn't work. Oh, never mind. Okay, yeah, I can read it. That's fine. Is everybody okay with this font? Oh, you got it. Okay. All right. Okay. So, all right. Now if argc is not greater than 1, right? Basically, that means if it is equal to 0, it is equal to 1, meaning that no command line parameters were given. Then what we want to do is essentially use the sonnet itself as our thing, right? So we've got that already, isn't it? So you can put a comment there, right there. You can start a comment, just right there, comment. So you can say, if no command line parameters were given, our sonnet already has all the lines we want. So that much should be clear. Everybody should follow that line and see that it works. Yeah. If no command line parameters were given, or arguments or parameters were given, our sonnet is already got all our default lines. No, next line is gone too wide now. Yeah, lines, plural. Okay, now we're at this is the same place where we were last time. So here you can say, one more blank line, and we'll flush this in really quickly, right? So what we want to do is, in fact, what we won't do that, say at and all, which is, escape codes. We're going to do this disappearing of a line, the easy, hacky way, which is to just print a /r and lots of spaces on the same line. Yeah, okay, that's easier. And that was fun, because when you want to do more 3D kind of work, like, spinning a cube like Chris was doing, then you want to position the thing. If you don't want to use the curses library and go really deep into it, like VI and all these editors use some hardware, not a hardware library, a library to position the cursor. But we won't do that. Okay. All right, great. So here's what we want to do. So you want to print the prompt saying, see out, watch out, your line is on its way. Watch out, a line, watch out, a line to remember is on its way. And then ... sleep 5 seconds. So this is stuff that we've done before. And so he's probably going to do it really fast. If any of you are stuck or need to have questions, you should just feel free to stop us and ask. Okay. So, all right. So now, yeah, sleep. And you can put the sleep right under the see out itself, because it's, the ... there. Yeah. I think it's sleep 2, right? How many? I sleep 2. Yeah, you can put it there. Oh, I see. I think it is UNISTD. Yeah. And then you also needed an SRAND and all. We can put that in later. Okay, SRAND and RAND and stuff like that. So we'll put that in later. All right. So sleep 2. Now watch. And now you're going to say print the line. No, I see. Now a line to remember is on its way. Now you're going to say read the line below, and you get read the line below. You get 5 seconds to look at it. Okay. Read the line below. You get 5 seconds to look at it. All right. Now you're going to sleep for 5 seconds. No, now you're going to print the line. Oh, now you got to get a random line. Endl, you're forgetting endls, by the way. You got to put endls here. Right. So by the way, he's using /n instead of endl. A lot of people do that. There's a subtle difference between the two. We won't go into the detail. Okay. Endl always flushes. /n doesn't always flush. Okay. All right. So all right. So read the line. Now you're going to see out the line. No. Is a semicolon there, and you can say your line is, right? See out your line is, and then the line, right? Yeah. See out your line is, and colon space, and then you want to say random line. We don't yet have a random line. We're going to pick a random line. Yeah. Yeah. So all right. So say yeah. So in fact, yeah, you can say above the first see out. No, not there. Just above the first see out. Yeah. There you go. No. After the sleep 2. Hit enter. You can say string line equals line. What did we call it? Random line. String random line equals and you're going to say sonnet dot sonnet square bracket rand open close percent sonnet dot size. Idiom, right? It's an idiom. That's why I'm just calling it off like this. Everybody okay with this? Everybody understand exactly what it does? So now we're going to print this random line here. See how your line is. All right. And then after that, you're going to sleep for 5 seconds. Endl there. Right. Yeah. And in fact, when you're doing the /n separately, it actually is better to use endl instead of /n. The reason for that, there's 2 reasons. One of them is endl is easier to type, because what he just typed requires shift key and all those things, multiple different kinds of characters. The other thing is that endl will automatically flush everything to the console. /n does not by default do that all the time, right? Okay. All right. So sleep 5. Everybody okay so far? Now we're going to erase that line. Okay. So now what we're going to do is, oh no, not endl, by the way. I'm so sorry. Okay. Instead of endl, you need, you need /r within double quotes like you did before, right? /r within double quotes. That says go to the beginning of the line. Oh, it did stopped. It did stopped. Your control Z works?
What?
You hit a control Z and it stopped.
Yeah, I forgot that I was the drum.
But you said Nano doesn't accept control G, control Z.
It doesn't accept control Z and undoing the thing. I tried to use it to undo.
Oh no, I was intending to get to. I see. Yeah, it is undo. Yes, I forgot that it's undo also. Right. No, it's, you just have to FG. It's already there.
What?
No, get out of this. Yeah, FG, because you just suspended it. It's just stopped.
No, it's not. Wait, is it?
Yeah. FG out of this. FG out of this. One more time. FG.
Oh, there we go. Okay.
Yeah, it's there in the background. FG is foreground. FG says bring something in the background into the foreground. Now, when you hit Control Z, it goes back into the background. There's FG and BG are two useful commands to know when you're dealing with the Unix shop. Okay. All right. Now you're going to erase the line. So after the sleep 5, hit enter a couple of times. No, it's just /r. You don't want to erase it right there. Just /r. Only /r. Yeah. Now, Now after the sleep 5, you put a comment there saying we're going to erase the line now, right? So say now we're going to erase the line. Yeah. Okay. Great. Now you can say C out, and then you got to put a lot of spaces there, I think, because you even got the prompt, your line is and all. Yeah. I think that's fine. Yeah, and you closed it, and then you want an endl after that. Endl after that. You can put a /n here. That's fine. Okay, so we used an alternate technique to erase something on screen today, right? Previously, we used go to that location and do these things. That has the advantage that you can do multiple lines because you're going to a specific location. But here, you're saying you're just going to erase the current line only. So you can just use /r, go beginning and wipe many times. Yeah, everybody okay with this so far? Everybody understand what the /r does? Caesar, yeah, you nodded your head, so I assume that you're good with this too. Yeah, Ian, you're not saying anything at all, and you're looking at your screen. Ian, are you good with this? All right, so you got to get in touch with one of us and get back in sync very soon. Okay, after class, everybody needs to be on in sync with this because it's going to be very similar to the code we wrote last class. So, but it's a useful program to know, and you should take this and practice, right? Endless practice, change these things. Like Isidore posted this thing, right? And it has a lot of scope for changes. You're just guessing a missing word. So you can already see that, it's different from what we're trying to do in class, but it's a new way of doing things. Yes. So new puzzle. It's it's the same structure, but slightly different. So you can come up with twists of your own. Okay. Maybe you decide that one of those words is going to be misspelled, right? You take a random word and then switch things in there and say, find out which one is the misspelled word. That's actually easy, isn't it? Because most humans can just look at. All right. So now erased it. Now you're going to print a prompt, right? You're going to print a prompt saying C out. Guess. What did we say? Type in the line you saw exactly, right? Including punctuation. Line you saw in exactly, yeah. Okay, and /n, and then on the next line you can say C out, and that's a prompt for us. You can say C out. What would you say? And type in here, okay? Type in and enter. Type in and hit enter. Type that, hit enter when done. Right now, you say hit enter when done. Hit enter when done. Yeah, press enter when done. Right, and then colon there, colon space. Yeah, right, and no endl. Okay, we're going to accept the input on that line itself. Okay, good. Right, get line, and then you want to say cin, comma, yeah, and what was it? We say input. Maybe create a new variable called input. Right. So yeah. It's actually good that we didn't get the code from last class and we're creating everything from scratch today, because I think that doing things more than once is always helpful. Okay, especially we did different people too, right? Jonah, Spencer, and so on. And hopefully we'll come back to Ian also at some point, and you've also got to code something like this. But doing it repeatedly, same thing over and over again, actually is hugely helpful, I think, right? All right. Now you're going to do the comparison, right? So on the next line, blank line one more, yeah. And you say if input equals a random line, random line. Yeah. Yeah, and then you can say hooray, hooray, you got it right. Otherwise, you can say, alas, you said this, but I expected that. That's all we had last class. Yes, it's good to go. All right. Now, if you want, you can put this in a loop, and you say, I'm going to keep on, until the user fails and dies by doing something wrong. You're going to keep on giving newer lines repeatedly. Okay, so that's a loop we can do, but you can. That's up to you later on. Okay. Now, by the way, also, Jonah, since these are just one lines for, let's not use braces, because it actually, if you look at it, adds 4 more lines to that if statement. Yeah. There you go. Excellent. Yeah, blank line after. Yeah. Oh, endl. You need an endl after random line. Okay. Now here's a cool thing. Okay. Now this program, if you run it without any arguments at all, it should give us a default behavior. Yes. Default is the same thing we had before. Let's compile it and run it. Compile it and run it. Yeah, I think make worked last time. Yeah. Oh, I see. Sonnet. Oh, sorry, size is yeah. So size needs the thing, the curly brace thing. No, the parentheses. Random line. Yeah, curly brace. No, the thing. Oh, this is very funny. These ancient domains that are automatically renewing. I need to go and clean up these things. Sometimes just paying money for these things and not even knowing. No, did you get it? Did you put the? Yeah, can I compile it? Oh, it doesn't. All right, get back to the code. Let's get back to the code. Yeah. Let's get back to the code. Well, all right. Sonnet equals, right? Hang on. Argc is greater than 1. Then it reads these things. Otherwise, sleep. Oh, we're not printing. Oh, we're not printing the line. Oh, we are printing the line. Oh, wait a sec. No, I think it probably. Can you print the line immediately after you got the random line? Just print it immediately after.
Where?
Yeah, right after that. Yeah, after the next line. Yeah, go to the enter, and it says I got random line equals.
What do you want?
Just say random line equals random line, right? Within quotes. So we just need to know what we got. Why didn't it print a line, right? Percent sonnet dot size. Oh yes. Thank you, Banani. Yes, thank you. Because we are doing a /r, we don't have a flush. No, we do. Oh, your line is. Yes, that's right. Yes, your line is, and then /r, you need to flush. Thank you. Right after the /r on the next line. Thank you, Panini. Yeah, totally forgot that. Yeah. Cout dot flush. Yeah. Did everybody understand what happened there? I totally forgot the flush. I think we used the flush last time, but I completely forgot. Okay. Now, if you run it, all right. So now we're going to get a line from the actual one. All right. Although our undivided loves are 1. Okay. So I can remember that easily. Right. All right. Great. Okay, great. So, all right. So now this works. This is the default behavior we're going for before. Now, what we want to do is try and create the thing that makes it more Unixy, right? So let's go and get another sonnet. All right. So go on to the doesn't have to be a sonnet. Just pick up a Zen. Not go on. What do they call it? Haiku. Right. Pick up a random haiku. Pick up a random haiku from from the internet, and put 5 lines. Put it in a file and call it Jonah's haiku or something like that. Jonah's haiku.txt.
There's a random haiku generator.
Oh, there is?
Yeah.
Okay. Well, anyone can, do a search the internet for a haiku or something like that and paste it in chat, and then he can just pick it up from chat and put it there. Oh, you got it? You got it there?
Yeah. So where do you want to put it?
Oh, I see. All right. So type this. Okay. Cat space greater than. Okay. Now these are all Linuxy things. Useful to know. What the greater than does is essentially, here's a command called cat. It's going to produce some output, right? And the shell looks at the greater than, the shell is what you interact with, looks at the greater than and says, hey, there's a greater than after the command. That means whatever output it produces needs to go somewhere. And where it needs to go is a file that's given to me after the greater than. So it's going to take this content and put it inside a file that's named after the greater than. Okay. So here, what we're going to do is, what is your haiku called? Does it have a name, Jonah? I call it Jonah haiku.txt, right? Jonah haiku.txt. Yes, exactly. And now paste it, paste, command V or something like that to paste what you had. Oh, I see. Okay. Oh, it's only 3 lines. No, that's okay. 3 is fine. Enter. You got to, yeah. Right now, hit Control D. Control D is end of file signal on the shell. Okay. That says, okay, cat is reading from the console, but Control D says that's the end of the input on the console. Go and take it. That's all it is. The buffer can be sent, right? That's what's going on. Oh, that was the name of the. It generated the haiku based on your prompt called box.
I didn't give it a haiku. I didn't give it a prompt.
Oh, it just made something up. Okay. That's okay. All right, box.txt, right? Now you type cat box.txt, you should see those 3 lines in there. Great. Okay. Now we're going to run this game, menjog, and give it box.txt as the first parameter. Okay. Right? Menjog, right? Menjog /menjog. No, it's already there. You already compiled it. Okay. See, this here, before you do anything else, see, make is clever, isn't it? It's like your ancient IDE. It says, you're asking me to compile menjog, but it's already compiled and no changes to source code. I don't need to compile it one more time, right? So it's intelligent, makes these intelligent decisions. No, you didn't, because if you had edited it, it would have make would have recompiled it. Oh, okay. Yeah. Yeah, I saw really cool, right? So now if he types it, okay, now see, it read 3 lines. It read 3 lines, and it did the behavior that we expected. Okay, it didn't take the default, but it took the. Including punctuation. Where is it? I didn't see the line at all.
It was an empty word. I think you missed it.
Oh, it is. Oh, I see. Okay. All right. Okay. All right. Great. Okay. So this is now we just added one small Unix feature, which is to say, if a parameter is given, don't do the default thing. Do what the user wants. Okay. That's what we added. But there are other Unixy things you can add to this, right? Like you can say, well, what if the user gets it and doesn't know what this command does, right? So you can give it another common flag that Unix programmers do is -H. Okay, -H is give me some help on what this command does. So it won't run anything. It'll just say, this is menjog. You can run it by giving it, and so on. So you just print this help message and saying, this is how you run it. That's the help message. Okay. One more common flag that I've seen Unix programmers use is -V, right? Where, you see where Jonah or Spencer is saying reading lines from, read 3 lines and stuff like that. After a while, it gets old. You don't want all that. You just want the behavior from the program, not all the extra shit. So this -V is verbose. And you say -V, it'll do all that. Without -V, it'll just be silent. Okay. So that's why I say, when you're 100% sure that your program works, then you can do the Unix thing. Say no news is good news, meaning I'm going to do my job, keep my mouth shut and do my job. Right. If not, you should be verbose, right? You have to exercise caution and say, I could fail, but I'm not going to, because you think about it. If you these days, especially on phones and devices, we have apps. If you fire up an app, and the app just, goes dead on you without reason, right? Just disappears from screen. I'm most likely I'm going to delete the app, right? If it gives back some information, it's got a better chance of staying on my phone. So most people have very little tolerance for things that don't work, especially things that don't work, and don't tell the user why they didn't work. Yeah. So those are the 2 things that we have to be super duper, careful about. Now, so far, is everybody okay? That's all we're going to do about menjog today. Now we're going to take the same menjog game and take it to the next level of saying, oh, all right, we're going to do this. I will come back to the next class too, because we're going to be doing functions and all. Okay. Next Tuesday. This is the thing that we said, we're going to give them give the player 10 numbers and they're going to guess the average. And many players are going to say, this is the average, but we'll find out who is the closest. Okay. So we'll at least do the shell code of this, right? All the comments and everything, so that you can now take it and flesh it out and share versions of it before Tuesday, when we'll actually do the complete game. What time is it now? Yeah, we got a half hour. Okay. So we have time to flesh out the shell of this code that we're going to do today, which is the averaging game, right? And we'll have to come up with a good name for average. We'll call it not memory average or something like that. Well, quick average. We'll call it quick average, right? Quick average. So you got to be quick in determining what the average is. And many people can guess. So there's going to be a variation to this, right? Because this is a game which is going to have multiple participants. When we run this game in class, we're all going to take turns, right? So maybe Vivian and Kiera and Juliana and Ben, they all say this is the average, right? So we'll have 10 players giving their averages, and then we hit return, and we say, all right, okay, now of all of them, Brian's number was the closest. Okay, and it's exciting and challenging because you also get to exercise more control structures to find out who the closest is. Now, before we even do this game, we need to get a strategy in our mind. Yes? Okay, before we start programming, we need to have at least a rough strategy. So someone tell me, what is a good strategy to find out the closest number from a bunch of numbers to a given number, right? The target. No, not you, because you just typed, okay, Jonah, someone else, right? So let's go with someone else. I'd like someone else to say, you can some simple strategy, okay? Simple strategy to say, I got a bunch of numbers, and then a random number comes along. No, I got a random number, and then a bunch of numbers come along. All I need to do is figure out which of those numbers is closest to this number, not identical, right? Closest. How can I find out? Does anybody have a strategy for that? Because exactly that strategy is what we're going to implement, okay? You got your hand up, Spencer? Okay.
Each number, or you can subtract the random number from each number in the list and get the absolute value of that, whichever thing is lowest.
Fantastic. Okay. Did everybody hear what Spencer just said? I don't know if the online people heard. The online people, did you hear what Spencer just said?
Can you hear me?
Yeah, well, Juliana is saying,
Hello?
partly. Who is this? Someone else said something here.
I was trying to speak.
Who is this, by the way?
Eric.
Where are you?
He's top left.
Oh, top left over there. Was the highlighting
Yep.
correctly?
Yeah, it was.
Yes.
Okay. Yeah, go ahead, Eric.
I was in the background, but it sounds like the user's number is subtracted from the number that was the how do I say this right?
Yeah, target number, whatever you call it.
Yeah, the target number. Yeah. So yeah, you just have the target number subtracted by the user's number, and that's how we get like approximation of how many you want. I can't really hear it that well.
Okay, all right. So it looks like some of what Spencer said did actually make it through to the electronics. All right, so he's actually typed it into chat also. Basically, what he's saying is that take the numbers and subtract them from the target number. So the number that is closest has got the smallest difference. That's all. So subtract them and then find the smallest difference. So there's just a couple of challenges for all of us here, okay? So, and we'll get to many of these only next class, really. Because now, how do you find the minimum of a list of numbers? That itself is, well, you actually do it, right? I do it in one of the quests, fine. But there you don't use a vector. You just get given 5 numbers, and that's actually harder, right? Finding the minimum from a vector is easier than finding the minimum from a bunch of numbers with names, and so variables with the names. So we're going to be doing it with vectors, and so it'll be a fun exercise for you too, right? We'll get to it eventually. So, but Eric and everybody else, Juliana, does everybody understand what Spencer said? He's also typed it in chat. We're going to find the difference, and then we're just going to say whose guess has got the least difference from the target, and that's the closest. That's all. Okay, that is a good, effective strategy, and so you can prove that there is no better strategy than that. Okay, there's no better strategy, meaning you cannot get the answer faster than that. Now, these are all don't seem like important now. To get into 2B and 2C, these are like super duper important. Finding is there a way to get faster? Is there, or even more in terms of mathematical proofs, is saying there is no way to get faster than this, right? And that is an incredible thing for lots of algorithms. Many people don't even know, is this the fastest we can do? But and then a researcher, after a lot of work, says, well, you know what? You cannot do faster than that. Whatever we have is the fastest we can ever do, no matter, even if in an alien civilization, as many millions of years ahead of us comes and works on this problem, you can tell them for sure, you can't do it faster than this, right? So we can actually prove logically and mathematically that certain things, this is the limit and we're at it, yeah? So I don't know how we got started talking about that. That is the fastest. You can't get to that because it's doing it in, it has to touch every number at least once, and we're doing that. Okay? Faster meaning you can get faster just by faster hardware and getting faster in terms of constant terms, but you can't get significantly faster. Meaning, what I mean by significantly faster is if an algorithm takes a square of the number of terms in order to process the data, it is slower than an algorithm that only takes as much time as the number of terms as linear. Okay, so it's like, you know, if you go a parabola like that, it grows much faster. The time taken goes much faster than a line that just goes like that. Okay, at some point it's going to cross, and a parabola is going to be slower. So so there's no that way you can get to a different order of magnitude faster. So this solution is optimal. Yeah, that's the word I was looking for. It's optimal. Yeah, okay. All right, so here's what we're going to do. Let's go and get into the code, and we'll call this quick avg.cpp, right? Brand new program, just like before. And here we're not going to aim to complete the program today, but we're going to put in a lot of comments, okay? That, you know, and you got to share this today, okay? So whoever's, you're coding now, right, Jonah? Unless someone else wants to go. Does anybody else want to go? Otherwise, want to take the screen? Otherwise, we're not going to compile, okay? So you don't have to worry about, you know, do I have a C++ that works and all? Most probably, we're just going to get the shell of the code and the skeleton of it, right? The skeleton of it, and share it on Reddit so that we can come back to this on Tuesday and work on it more. Yeah. And on Tuesday, we're going to do some group working. So meaning that we'll get to it get the program to a certain stage where you can basically just interact with other people and flesh it out, like we did in a previous class. Okay, so we're going to do that. You come prepared for that. Hey, Helen, you're sleepy already. Okay, I saw you yawn. Okay, all right. Okay, okay. But anyway, we're coming to the end of class. So all right. So how about Jonah? If nobody else wants to take the screen. In fact, if you're feeling sleepy, like, you know, Brian or Helen, you should in fact take the screen, because in the past, when I was a student, I found that when I was sleepy in my professor's classes, the best trick I had for not feeling sleepy is just to volunteer for anything the professor asks. And then once you volunteer, your sleep has just disappeared. Okay, I can tell you that for guaranteed. It just goes. You don't even feel it gone. You say, oh, I got to stay awake. No, not like Rowan Atkinson and, you know, like that. It's gone. So you just volunteer. If you feel sleepy, you should volunteer. All right. So nobody volunteers? Can't see anything in chat. Someone said in chat. Is anybody volunteering? Otherwise, you know, Jonah is going to just continue. Yeah. Okay. Nobody's volunteered. All right. So next class, I'm going to ask for people to volunteer. Okay. I'm going to volunteer you guys. Call it a quick avg.cpp. No, it's going to be a command. So just call it quick avg, no underscore. No underscore. Because it's going to be a command and all.
Oh.
Quick avg, yeah, .cpp. Yeah. All right. So now let's comment right at the top. Comment right at the top. And so this is going to be a game. This is going to be a game in which we pick 10 random numbers. We're going to describe the entire game right in the comments in the first 3 lines, so that even if we don't manage to complete the rest of it, you'll have a good idea, because you got like the Thursday, Friday, Saturday, Sunday, Monday, right? Tuesday. So you got a lot of time. So this comments will be enough for you to just flesh out the rest of the code, even if we don't get to it. Okay. And it's going to be good exercise. If you can at all, don't wait for Tuesday. Take a crack at it and publish your own version on Reddit. Okay. All right. It's going to be a game in which we select 10 random numbers from 0 to 1,000. Next line, I think. Yeah. Right. 10 random 0 to 1,000. Print them out on a line. Ask the user to estimate the average in 5 seconds. Yeah, break the line. Go on to the next line. Estimate the average within 5 seconds. Then erase all the numbers and ask the user. No, then and then question mark. Then and colon. Then we've got to do a couple of things. Okay. Then right on the next line. Number 1. Number one. Oh yeah. Then erase all the numbers. Yeah. Then erase all the numbers. Number 1. Then ask the users to enter the names of players one by one, ending with a blank name. Right. One by one, ending with a blank name. There you go. That is your cue, right? That is a clue for saying, I'm going to be in a loop reading names from the user. When do I stop? Is it an infinite loop? No, we have a stopping criterion, and the stopping criterion is whenever your user says my name is blank. Okay, that's the last player. Okay, all right. So ending with a blank name. How are you going to do that? Okay, erase all the numbers. Ask the user to enter the names of players one by one. Okay, ending with a blank name. Okay, all right. That is the first step. Right, that is the first step. Hang on. Ask the user to answer maybe. No. Yeah, that is the first step. Erase all the numbers. First step. Yeah, one number. And number two is ask the users to enter the names. Yeah, okay. And now, and on the next line, part of two itself within parentheses, you can say now we should have a vector of player names. Okay. You know how to get a vector, like vector of player names? Everybody knows that because we read a file and took all the lines and stuffed it into a vector. Yes. You're going to do exactly the same thing, except you're going to read lines from the user typing in, right? Brian, enter. Right? Isidore, enter. Raj, enter. Right? You're going to reading, and each of those is going to go into a vector, just like you're reading lines from a file and putting. So at the end, you'll have a vector with, n player names. Yes or no? Everybody okay with this? All right. So that's what we're going to do. Now we should have a vector of player names. Okay. Now you cycle through. Now you iterate. Yeah, iterate or loop through. Loop. Now loop through all of the players. Ask each one to enter their estimate of the average. Yeah. Okay. Number four. Find the closest match using Spencer's hack. Okay. Find the closest match to the actual average. Yeah. Find the closest match to the actual average. Does everybody know how to calculate the average? Right. By the way, right. You got 10 numbers. You got to find the average yourself, right? In order to compare it. So everybody know how to find the average? Yeah? Okay. So you're going to find the average, and then you're going to use Spencer's hack to find which of those players got the closest to the thing, right? And then on the next line, you're going to say, hooray, XYZ won the game with this guess. Okay, that's all. And if you're feeling, enthused enough, you can take it upon yourself. This is harder. Okay, this is harder. If you do this, I'll give you extra credit too, right? Not just a first place winner, because you're going to be the closest, and then you're going to have second closest, third closest, and so on. Okay, so you're going to be printing that too, right? You don't have to print all of them. Print second and third, first three places like the Olympics. So you can say first winner, second place winner, third place winner. Yeah, and I think it'll be an exciting game, right? Because we can actually play this in class. Because one of the things I've done many times is, even when I see billboards, even car license plates, just to keep my mind occupied, sometimes I just do some random math calculation on calculate the average and all, and I try to see, how close is it to the actual thing? And sometimes I actually get the actual number and I can compare it. Lots of people do that. Okay, not just me. I found out because by talking to other people like me, I found lots of people do that, right? So when you give them a bunch of numbers, when they're just noodling on this and say, all right, that must be the closest. And you actually do this many times. It's related. Okay, if you find yourself doing this, maybe there you do this too, right? Sometimes what you do is try and locate things on the screen. Just do things on your computer screen, like find locations. And then when the actual location comes in, you say, that was my location. And how. Actually, there is a game that Panini once wrote, I think it's drawing a freehand circle and seeing how close it is to an actual circle. Because when you draw a freehand circle, it's harder, isn't it? There's algorithms you can use, and simple algorithms you can use to find out how close the circle is to a real circle. And you can find the minimum error between the circle you drew and a real circle. And a lot of people get satisfaction out of that. Just by, repeatedly drawing circles, repeatedly drawing squares, identifying places and seeing if they were actually correct by, and so on. So I think this will actually be an addictive experience too. Mildly addictive, not too addictive, but mildly addictive. So when you're on train, for example, you can sharpen your powers of mathematical estimation, right? So it doesn't have to be 3-digit numbers anymore. Maybe 10-digit numbers. Not 10-digit, obviously. But even 10-digit numbers, you can train yourself, right? 5 10-digit numbers. What's the average? And you can actually find out ways in which you can get to the average without actually having to do all these complex things, right? It's got to start with a 2, right? And it's got to have like this many digits. And you can rule out like A, B, C, D, right? Choices like multi-choice and do those things. You can come up with interesting ways of doing these things. So take this game to the next level. Okay, it doesn't just have to be averages. It can be more. In fact, you can even do more. If you feel you can do this, you can even present a quadratic equation. for 5 seconds, right? Simple quadratic, right? You're having integer roots, not, like fractional roots or imaginary roots, and say, factorize that in 10 seconds. Okay, and it's going to disappear, and you're going to type in the factors. Yeah, so you can knock yourself out. It doesn't have to be Sonnet, doesn't have to be math. Find things that, the thing that you can leverage is that you have this ability now to create any game that has memory as one of the components. Yes, and there are lots of games you can do with this. Lots of games. You show a picture and say, how many arms did that spider have? Yeah. So it's like captchas. This is captchas, isn't it? This could be a new kind of captchas that use memory, right? Because right now you only have captchas that use your ability to hear and see clearly, right? Maybe you can also have a captcha that uses memory, and so you're going to be shown that, and you got to remember how many cars were in that scene, right? So, and that is and that's also easy for AI to do these days. But these are interesting games you can play. So the point of this is that it's not just one way of doing this. There's many ways you can take this angle, just like the code that Isidore shared and Raj and Akash. You should look at all of that code as just starters. Okay, starters that some of your classmates are sharing, so that you can take that and just fly. Because the sky is your friend. You don't have to go in any particular direction. The idea is not to develop anything in particular in this class, okay? I'm not asking you to develop anything in particular, except the quest. You got to solve all the quests. But in your programs, you don't have to do anything in particular. The idea is to just find things you can work on for no reason at all, okay? And we're getting lots and lots of good reasons. People are cutting code, sharing it on Reddit. Okay, you just have to take one of them. It doesn't have to be any particular one. Take one of them. If you don't understand one, go to something else and do it, right? And play with it. I hope we get lots and lots of opportunities to just keep coding, okay? Because today, when we're doing so many classes, many of you are enrolled in many classes, doing challenging classes and all, the competition for your time is high, especially not only classes. You're doing Fortnite, you're socializing, you want to have time to go and have a drink with your friends and, and find your life partner in college. So many things competing for your time. So you got to be really, really careful. Classes can compete on the side by trying to be more interesting. So hopefully we're finding interesting things to do in class so that you have an excuse really to come back to this. Because if you don't have an excuse, you're not going to come back to it until Tuesday. Yes, most of the time that's what happens. We come up with interesting things we do in class, and I say, take it and do something really cool, okay? But many times in the past, I go to the next class, even though it's next week, like 5 days later, we're still on the same page. No, that means it's not a fault of you guys, okay? It's just that the material that I've been teaching or the problems I've been setting you up with, not exciting enough to hook you into that next level, okay? So I got to be doing that until that happens, but hopefully this will work, okay? So take that, this is a hook, grab that, take that and play with it, okay? Play with it and do more stuff. Is that okay with all of you guys online also? We got 4 minutes more. We don't have to, continue with the rest of the thing. But basically this is it. That comment that Jonah has got is essentially what we got to do. I don't want to fill in anything in the main. I think everybody's got a fair idea of what you got to do in main, yes? If not, it only takes one person to do the whole thing. Someone will say, all right, I'm going to do something similar. Don't worry, you can copy the whole thing and then hack it. Copy and hack, that's okay. It's only quest code is the only thing that you shouldn't copy and hack, right? So this copy and hack. Someone, Raj posted it, take it, fork it, and then do your own version. That's okay.
You want me to post this next to Reddit?
Yeah, post this too, right? And also put a comment. No, before you post it, put a comment saying this part is intentionally empty. You should do what people do inside of main. This part intentionally left blank. Okay, they say this page intentionally left blank. Okay, this part intentionally left blank. Develop your own version of this. Even if it doesn't work, share it on Reddit. Someone else will take it and try to make it work. Still not working, someone else will do it. So it'll be like a group project, okay? All of us here in class, online, all of us together, we're going to develop this. Hopefully before Tuesday. You need excuses to come back to this. And hopefully this is enough of an excuse, okay? Over the weekend. So maybe take a couple of hours off from your video games. You say, I'm going to do this for a couple of hours, okay? And it'll be fun. And hopefully, right? Maybe you take time away from playing games to do this, but you're creating a game that other people are going to give you time for. Yeah, I'm going to play that person's game. You're actually taking someone else's time now. Okay, so you're on the other side. Instead of being a consumer, you're being a producer. Okay, being a producer is actually a great deal of fun. Okay, I think you'll have a great time doing this. Was this useful? Was this class useful? Did we cover any useful stuff today that you think you can use in your? Yeah. Okay. Great. Hey, Kira, you guys are very silent. Okay, I didn't look in your direction that much today. Are you guys okay? Pretty sleepy, Kira. You look kind of tired and all. You okay? Yeah. Okay. Good. Good. Ian. Good. Okay. Caesar, you good, right? Hey, Ian. So you need to get in touch with. Get this program done. Yeah. Okay. All right. So if you need any help, you just need to reach out. This some of us we can sit with you, right? Yeah, we'll all help. We'll all have. The goal is on Tuesday. Everybody should have some version of this. Okay, whether it works or not, everybody should have some version of this game on Tuesday. Is that okay? Is that a plan? Okay, get it done before Tuesday. Don't wait until Tuesday and say, "Oh, I got a class tomorrow. I got to do it." No, do it. Do it on Saturday. Do it on Saturday when you got some time. Okay, and so that on Tuesday you just need to put some finishing touches, or even even if you have something doesn't work, that's okay. You'll have something. You won't have to hastily put something together, hoping that, well, I got some class and I got to do this. Yeah, is that okay? All right, I'm actually glad we managed to do this today, and I think we covered everything that I wanted to, except that I thought we'll do more of this program, but I'm glad we didn't, because I think you guys can actually do it. I don't want to dive in and do everything. And suck the fun out of it for you guys. Okay, so I think we left it at a good place today. I'm very pleased. Okay, hey Helen, were you okay with today's class? Yeah, I know some of you were starting to feel sleepy because it's tired and it's hot also. When it's hot, I think you tend to feel more sleepy too. But I still hope that all of you had got useful stuff out of it. You need to take notes. It's going to be recorded, obviously. Is it recorded? Oh, it is. It is being recorded. Yeah, I'll put it online. Maybe tomorrow, day after. I'll download it and put it on our channel. But you'll see all of this. And 7:50. We're on time. Thank you all so much for sticking with the class and not taking off. Sometimes I see students taking off before class ends. You're all with the class. I appreciate that greatly. Okay, and so the only way it could get better is all of you start working together now, right? So now you've got all the tools. Now all you need is just company and working together, and that I think will be fostered by these programs you work on Reddit. Thank you all so much. Okay, I'll see you on Tuesday. Have a good weekend.